Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shane, coming to you live from Summit Academy. In this video, working on that unit number 7, lesson number 6. Still talking about some exponent rules, but our objective for this lesson is we will be able to use the exponent rules for bases other than 10. So we've been practicing almost like scientific notation where our base is 10, but now we're going to have different bases other than 10. So it says, first part, true or false, comparing expressions with exponents. Is each statement true or false? So for that first one, it says for number 1, it says 3 to the 5th power is less than 4 to the 6th power. And this is going to be true, and it says the base and the exponent on the left are smaller. So if we were to get those values, we would say that this is going to be less than 4 to the 6th power. Then it says for number 2, it says negative 3 squared is less than 3 squared. This is going to be false because when you square a negative, the result is positive. So this should be equal, actually. And then for the next one, it says, for number 3, it says negative 3 to the 3rd power is equal to 3 to the 3rd power. And we're going to say this is also false because when you cube a negative, the result should be negative. And then for number 4, it says negative 5 squared is greater than the opposite of 5 squared. And we're going to say this is going to be true because a positive is always greater than a negative, and so when you have negative 5 squared, that should be a positive number. Where when you have the opposite of 5 squared, that would end up being negative 25. Then for the next part, it says complete the table to show what it means to have an exponent of 0 or a negative exponent. So as they're moving to the left, they're multiplying by 2. So what we can do is we can write in here and saying, okay, well, what number do I need to multiply 2 by to get 16? Well, we would say this would be 8, this would be 4, this would be 2. It's almost like we're dividing by 2 as we move to the right now. So we have this is going to be 1, this is going to be 1/2, this is 1/4, this is 1/8, and this is 1/16. So, as you're moving from right to left. So as we're moving to the left, it's like we're multiplying by 2, and as we're moving to the right, we're dividing by 2. And so for that exponent form, we can say, okay, well, it's like we're decreasing that exponent by 1 each time. So when we're dividing by 2 each time, we are subtracting from the exponent. So we're going to say this is going to be 2 to the 3rd power, which is 8, 2 squared is 4, 2 to the 1st power is 2, 2 to the 0 power is 1. Now we have our negative exponents because notice how our exponents are decreasing by 1 each time. So we're saying it's going to be 2 to the negative 1. It's going to be 2 to the negative 2 power, 2 to the negative 3. I can draw that 3 out, there you go. And 2 to the negative 4 power. So just be able to see that pattern, as we're moving left to right. And it says, as you move toward the left, each number is being multiplied by 2. What is the multiplier as you move toward the right? Well, I said it's like we're dividing by 2, which is the same as being multiplied by 1/2. So for each time, it's like we're multiplying by 1/2 for each part. So 1/2 for each part. So be able to notice that pattern as you're shifting around. And again, make sure you're understanding those exponent rules for different bases. Underneath of that, it says use your patterns you found to write 2 to the negative 6 power as a fraction. So if we were to write this as a fraction, again, to get rid of that negative, again, this value is not negative, but it just stands for that the exponent is needed to move it to the bottom. So I have this going to be the same as 1/2 to the 6th power in that fraction form, which is the same as 1/64. Then for the next one, it says write 1/32 as a power of 2 with a single exponent. So I can say, okay, 1/32 is going to be the same as, where's that here? I can have 32 is the same as 2 to the 5th power, so I have in the denominator 2 to the 5th power, which if I wanted to write that as a single exponent, I would just say 2 to the power negative 5. All right. Now for the next one, it says, what is the value of to the 0? Well, any non-zero number to the power of 0 is just going to be equal to 1. And for number 5, it says, from the work that you've done with negative exponents, how would you write 5 to the negative 3 as a fraction? So what we can do is we can write it like this. We can say, if I have 5 to the negative 3, I have 5 to the negative 3, get rid of that negative exponent by writing it in the denominator. So I have 1 over 5 to the third power, which is the same as 1 over 125. So I wrote it as a fraction. And the last one, same kind of setup, write 3 to the negative 4 power as a fraction. So I'm going to say I have 3 to the negative 4 is equal to 1 over 3 to the fourth, which is equal to 1 over 81. So make sure you can, to get rid of that negative exponent, I just move it to the denominator. Then for the next part, it says exponent rules with bases other than 10. So this is what we've been practicing, but let's make sure we can get this solidified. It says for each list of expressions you choose to analyze, decide which expressions are not equivalent to the original. So it says Lin's original expression is 5 to the negative 9 power, and it gives a list of values. So we're going to say, for this first one's good. However, the next one, we're going to say this is going to be wrong, because we can say 5 to the negative 9 is positive. Even though it has a negative exponent, that just means it's going to be a small number. Then we could say this one's going to be good because they subtract the exponents. Then for the next one, we're going to say this one's going to be wrong. We could say because this is actually equal to, let me write it up here. Let me say if I have 5 to the third power with the exponent of negative 2, that's almost like we're multiplying those exponents. So I do 3 times negative 2 and the exponent, which is equal to 5 to the negative 6 power, which is not what we're looking for. Then for the next one's also incorrect. Again, we have to subtract the exponents. So what I have to do is I have to say it like this. I have to write, I have 5 to the exponent of negative 4 minus a negative 5, which is equal to 5 to the negative 4 plus 5. So make sure you're careful on those integer rules. And so this is going to be equal to just 5 to the first power. Again, we're looking for, our end goal is the original expression 5 to the negative 9, which this one is not. But the last one is good because if I added negative 4 plus negative 5, that one is correct. And then for number 2, it says Noah's original expression is 3 to the 10th power, and it gives a list of values. So let's see which ones work and which ones do not work. So for that first one, again, you have to add the exponents. So this would be 3 to the 5th power plus 2 in the exponent, which is equal to 3 to the 7th power. So that's why that one's not right. However, these two are good because we multiply out. So I'm going to put a green check on that one. Then for this next one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I expanded it out, I have 3 to the 10th power, so that one's good. If I was to flip this fraction, I would have 3 to the exponent 10, so that one's good. Add the exponents together, this one's good. If I subtracted 20 minus 10, I would get 3 to the 10, so that one's good. And then that last one, however, is going to be, so for that last one we're going to subtract the exponents since we have division, and so that one's going to be wrong since we have this is going to be 3 to the 20th power minus 2 in the exponent, which is equal to 3 to 18. So that's why that one's wrong. So again, make sure you're seeing those exponent rules that we've been working with. Then on the back it says write with a single exponent. So for example, if it has 1 over 10 times 1 over 10, that's going to be 10 to the negative 2 power. So we're just kind of combining these, and again, this is from that lesson number 5 practice, but I just wanted to go back and make sure we got this. So if I count this together, I have 1, 2, 3, 10's in the denominator, so that's just going to be 10 to the negative 3 power. Same kind of setup if I have the next one. I have 1, 2, 3, 4, 5, 6, 7. So that's going to be 10 to negative 7 power because those 10s are in the denominator. Then for part C, I have 1, 2, 3, 4 10s in the denominator. So if I wanted to write it like this, I would say that's like I have 10 to the negative 4 power squared, and I would multiply those two together, so that would be 10 to the negative 8 power. Same setup for this one. I have 1, 2, 3 in one of those sets of parentheses, so I'm going to say I have 10 to negative 3 to the third power, which is going to be equal to 10 to the negative 9 power. And lastly, if I wanted to flip those, again, it's almost like I'm writing it like this. So let me write, say I have 10 to the third power to the negative 2 power, which is equal to 10 to the negative 6 again. So again, just make sure you're seeing those rules when we're working with those negative exponents. Same kind of setup though, it says write each expression as a single power of 10. So I'm going to say for this one, I add those exponents together. So since I add those exponents together, I have negative 3 plus negative 2 is going to be 10 to the negative 5 power. Then for the next one, I have 4 plus a negative 1 is going to be 10 to the third power. However, since I'm dividing, I have to subtract. So I'm going to say this one is going to be 10 to the 5 minus 7 power, which is equal to 10 to the negative 2 power. Then for the next one, I have to multiply these two together. So I'm going to say I have negative 4 times 5 is going to be negative 20. So I have 10 to the negative 20 power. Add my exponents for the next one. So I'm going to say I have 10 to the negative 1 power. And then I'll subtract these two. So this is almost like I have, change this up, let me do 10 to the negative 9 minus 5 is equal to 10 to the negative 14 power. So again, be careful when you're working with these operations. Make sure when you're multiplying with the same base, add the exponents. When you're dividing with the same base, subtract the exponents. And when you're raising it to a new power, make sure you multiply those exponents. And then for number 3, it says select all of the following that are equivalent to 1 over 10,000. So for that first one, again, negative exponent, just put it on the bottom. So I'm going to say this one is good, so I can put a star by it. For B, however, that one's not good because that one is a negative number. So again, negative, which this value is not. However, the next one for part C, or choice C, this one is good because if I flipped it over, I'd have 4 zeros. So if it's almost like I'm writing 1 over 100 squared, which is the same as 1 over 10,000 with 4 zeros. Same idea with the next one. I can say this one's good because it has 4 zeros in the denominator. However, for that last one, even though it has a negative number, it's not what it's going to be looking like because we're saying that this is, there we go. When I say that's almost like it's what that would just be 100, which is not what we're looking for. So as long as you're able to use those rules carefully, you'll be good. Move on to lesson 6 practice. It says Priya says I can figure out 5 to the 0 power by looking at other powers of 5. It says 5 to the third power is 125, 5 squared is 25, then 5 to the first power is just 5. So it says what pattern do you notice? Well, we can say this. We can say when the power of 5 drops by 1, the value is divided by 5. So, as you're decreasing that power, it's almost like we're dividing by 5 each time. Then for part B, it says if this pattern continues, what should the value of 5 to the 0 power be? Well, we're going to say that's just going to be equal to 1. The value of 5 to the 0 power should be the value of 5 to the first divided by 5. So since 5 divided by 5 is equal to 1, we're going to say that 5 to the 0 is equal to 1. Just remember, any non-zero number to the power of 0 is equal to 1. And then for the last part, for part C, it says if this pattern continues, what should the value of 5 to the negative 1 power be? Well, we're just going to move that as a fraction. So we're going to say it's going to be 1/5. And we say the value of 5 to the negative 1 should be the value of 5 to the 0 power divided by 5, which we would say that's just going to be 1 divided by 5. Then for number 2, it's to select all expressions that are equivalent to 4 to the negative 3 power. So again, if you wanted to, you could say on the side here, if I have 4 to the negative 3 power, that's almost like it's 1 over, is that 4 to the third, which is equal to 1 over 64. So I have a couple different ways of writing it just like that. But we're going to say for that first one, again, that one's definitely not right because it's a negative number. However, this one, it is going to be right because if we wanted to change it, it's almost like we're doing 2 squared times negative 3, which is the same thing as 4 to the third. So that one is good. Like we have for C, that one's also good because that's similar to an easier one we had. If I wanted to expand it out in fraction form, I would choose D, so D is good. However, E is still not good because it's a very small number. It should not be equal to 12. Also, F is not good because it's not a negative number. And lastly, G is not good as well. So it's just those middle three. Then for number 3, it says write each expression using a single exponent. So for this first one, I'm going to subtract the exponents. I'm going to subtract the exponents because I'm dividing. So I have the same base, so I'm going to say this is going to be the same as 5 to the third power minus 6 in the exponent, which is equal to 5 to the negative 3 power. Then I can say for the next one, we are multiplying the exponents together because we are raising a power to a new power. So we're going to say this is going to be 14 to the third power times 6, which is equal to 14 to the 18th power. Then for the next one, we're saying we are adding those exponents. So add the exponents. So this is going to be 8 to the power 3 plus 6, which is equal to 8 to the 9th power. And for the next one, we're back to subtracting. So I'm going to say subtract. And so we're going to say this is going to be 16 to the 6 minus 3 power. Let me write that a little bit better. 6 minus 3, which is equal to 16 to the third power. And for that last one, we still multiply. So again, I can click that one. There we go. We multiply. So we're going to say it's going to be 21 to the third power times negative 6, which is equal to 21 to the negative 18 power. So just make sure that you're setting those up carefully. Then at the bottom for those exit tickets, I'll go through them with you so that way you can see how they work. So for that lesson 5 exit ticket, it says mark each of the following equations as true or false. Explain or show your reasoning. So we're going to say that this first one is going to be false because that right side is a negative number. However, that left side is a positive number. Then for number 2, we're going to say this one is actually true because they're both equal to 10 to the negative 6 power because we multiply those exponents. Then for the last one, this is also true because if we divide, it's almost like we're taking and subtracting those exponents. So we have 10 to the third power minus 14, which is going to be the same as 10 to the negative 11 power. And then on the right side, for the lesson 6 exit ticket, it says Diego was trying to write 2 to the third power times 2 squared with a single exponent and wrote 2 to the third power times 2 to the second power is equal to 2 to the third power times 2, which is equal to 2 to the 6th power. Explain to Diego what his mistake was and what the answer should be. So it says Diego multiplied the exponents when he should have added them. And it should be 2 to the third power plus 2, which is equal to 2 to the fifth power. And then it says for the second one, it says Andre is trying to write 7 to the fourth divided by 7 to the negative 3 power with a single exponent, and wrote 7 to the fourth divided by 7 to the negative 3, and they subtracted the exponents and got 7 to the 1 power. Explain to Andre what his mistake was and what the answer should be. Well, the mistake is in the subtraction. It should be minus a negative, so make sure you're writing it like this. It says Andre should have done this, so it should have been 7 to the fourth power minus a negative 3, which is almost like it's adding the positive 3, so it's going to be 7 to the seventh power. So make sure you're asking questions as they come up, and as always, super slam that subscribe button.